Hello and welcome back. We are ready for the last section of Unit 6A, Circles. And we are going to kind of switch gears one more time in this unit and work with arc length and sector area. So we'll actually review a little bit of circumference and area formulas, and then we're going to get into finding the length of an arc and also the area of a sector of a circle today. So let's start by reviewing circumference and area. So the circumference, remember, is the distance around the circle. And we also refer to it as the circle's perimeter. Okay. Area, however, represents the square units, the number of square units of the circle. So I think I just put the square units. Okay, it's kind of like filling the circle. And we have some formulas of which circumference, there's really two formulas, and sometimes it's easier to use the other one, but our circumference formula is C equals 2 pi r, but if you remember, 2 pi is actually the diameter. So when they give you the diameter, like I typically will use pi d for circumference of a circle. And a lot of times it's going to be quicker to use pi d than 2 pi r, because they give you the diameter. So I'll talk through that when we go through some problems. When we get to area, however, area is just pi r squared. So we do need the radius for area. Okay, so of course, r is the radius, and then d would be the diameter. Okay, so you kind of choose which formula to use, and then, kind of pay attention to how they want to leave your answers. So some of the questions are going to be like number 47, where it says find the circumference and the area of the circle, and then it says leave your answer in terms of pi. So I'm going to talk about in terms of pi, and a lot of our answers today will be in terms of pi, which means we're not going to be multiplying by 3.14 or the pi button on your calculator. All right, so whenever you're going to work on a formula, always write the formula first. So we want to find the circumference. So for circumference, remember, you could use 2 pi r or pi d, but since in this problem they actually gave me the diameter, it's 10, it just makes sense not to break it down. So I'd have pi times 10, or 10 pi, and this is inches. So it's really a linear measurement, so it's just inches. So this is our distance around the circle. Okay, that's our distance around the circle. Okay, now when we go to do area, we're talking about the number of square units that the circle encompasses. So let's do the area formula, which is pi radius squared. So if the diameter is 10, that means that the radius is 5. So area is pi times 5 squared, which is 25 pi. And this time we'll use inches squared. So notice we left our answers in terms of pi. We did not multiply through. Okay, and so that's just neater all around, because then everybody has the same looking answer instead of some people rounding it one way, so other people rounding it a little differently. If we had to actually go to the store and buy materials for a project, well, then we would want to multiply through by the 3.14 or the pi button. All right, so let's practice another problem. So this is kind of a typical problem. It says find the area of the circle, okay, that has a circumference of 36 pi. So find the area, but they gave us the circumference. Okay, so if you think about it, area and circumference, they have something in common. Okay, they both, of course, have pi, but they're really connected by the radius. So since they've given me the circumference formula, they gave me the circumference. Now I know circumference is pi d, and so they told me actually that their circumference is 36 pi. So I can say, well, 36 pi equals pi d. Okay. Well, the pi's would cancel if I divided out the pi's. And we can see that the diameter would have to be 36. If the diameter is 36, well, then I know the radius must be half of that, 18. So I was able to pull the radius from the circumference. Okay. If the circumference is 36 pi, 36 has to be the diameter. What half of that is 18? 18 is the radius. So now I can do area, which I know is pi radius squared, okay, and plug in 18. So pi times 18 squared, and 18 squared is 324. So the area is 324 pi centimeters squared. Again, I left it in terms of pi. They didn't ask for that, but they did before, so we'll just leave it in, go ahead and leave it in terms of pi. So if they don't say anything, let's go ahead and leave it in terms of pi. All right, number 49 says, the diameter of a monster truck wheel, including the tire, is about 1.7 meters. How many meters will the monster truck travel if the wheel rotates 1,000 times? Okay, so let's think about this. We have this wheel, and it has a diameter of 1.7 meters. Okay. And now this wheel's going to rotate 1,000 times, which means it's going to, go forward. So we want to know how far it will travel if the diameter is 1.7 meters. Okay, so what we could do is we could go ahead and find the distance around the circle. Okay, and then as it rolls, each time we can multiply by 1,000 to get our distance. So let's first figure out how far around the circle is. So we know that the diameter, so if I do circumference equals pi diameter, that means circumference is 1.7 pi. So again, since this is more of like a real problem, they're going to ask us to use, 3.14. So I will do that, but I'm going to wait until the end. I don't want to use it too early because then you've already rounded. So basically, if we want to know 1,000 times, we'll just take 1.7 pi times 1,000, and that'll tell us how many meters it traveled. So now I'm going to type in 1.7, and I'm going to use times 3.14. That's what they told us to use. And then times 1,000. And we're going to get 5,338 meters. And that would be our answer. All right, so that's a little bit of review of area and circumference, and it's good we reviewed because we actually need those two formulas for the next two parts, which would be arc length and sector area. So let's talk about arc length a little bit and how it's different from arc measure. So arc length is actually a linear measurement similar to the length of a line segment. So when we talk about arc length, we're really talking about inches and we're talking about feet. So arc length is actually measured in units, whereas arc measure is measured in degrees. And degrees, we're always going to be out of 360. So your sum fraction of 360 when you're doing arc measure, it might be a 40-degree arc, it could be a 25-degree arc, 100-degree arc. But when we know that circles can be different sizes, so a 100-degree arc on one circle could measure actually different linearly than a circle, that has a 40-degree arc. So, or I'm sorry, a 100-degree arc, but maybe a bigger circle. So circles are different sizes, so their arc lengths could be different. Measured in units, a fractional part of it's really a part of the circumference. All right, so we have a little proportion formula that we use to find arc length. And so if we take a look at this formula, we have arc length over the circumference, which is 2 pi r, or you could use pi d, is equal to arc measure over 360. Okay, so they're a direct proportion. The length of the circle's arc out of the circle's circumference is the same as the arc measure out of 360. Okay, so hopefully that makes sense. All right, so what we're going to do is practice. It says find the arc measure and the length of an arc intercepted by a 40-degree central angle. So let's draw a picture. Do a little circle here. And let's say here's my 40-degree central angle. Okay, so if the angle is 40 degrees, well then we know the arc, if it's a central angle, we've already learned this, we know that the arc is also 40 degrees. So we know the arc measure, okay? But now we want to know actually how long the arc is. So that's going to depend on the circle's radius. So the circle has an 18 centimeter radius. So we can find the length of the arc using this proportion. So arc length we don't know, so I'm going to let that be x, out of 2 pi r, so 2 times pi times 18, so that's going to be 36 pi if you'd prefer. And arc measure is 40 out of 360. Okay, there's always 360. So now we'll do some cross products. Okay, so we have 360x equals, and I'm going to leave this in terms of pi, so what I'm going to multiply is the 40 times the 2 times the 18. And 40 times 2 times 18 is 1,440 pi. Okay, so don't type in the pi into your calculator. Don't type the 3.14. Let's leave it in terms of pi. So divide by 360. Again, just divide the 1440 by 360, and you get a very nice 4 pi. So the length of the arc is actually 4 pi centimeters. And if you really wanted to know, what that is, well, you can take 4 times pi, and you get about 12.6 centimeters, approximately, okay? But in terms of pi is so much neater, so a lot of times we're asked to leave it in terms of pi. So that's kind of the difference between arc measure and arc length. All right, let's try another one. It says find the length of arc AB. Put a little arc symbol in there. And so to do that, again, we're going to use our little proportion. So we want to find arc AB. Now I know its measure is 25, okay, but I don't know how long it is in meters. So we're going to use x out of, now I'm going to need the circumference. So 2 pi r or pi d. So pi times 20 is 20 pi. Okay, and then we have arc measure, 25 out of 360. Okay, so we did arc length out of the circumference equals arc measure out of 360. Now we'll do our cross products, and that'll give us 360 pi equals 25 times 20, which is 500. Oops, I'm sorry. I made a little mistake here. Let me start over. 360x equals 500 pi. There we go. Now we'll divide by 360. Okay. And so for this, 500 is not going to divide exactly by 360. There's a couple things you could do. You could get the decimal, 500 divided by 360, which is like 1.38 repeating pi. There's one way to do it. Okay. You could also just reduce the fraction. So 500 divided by 360, and then hit on your calculator math fraction, you actually end up getting 25 over 18 pi. And I can show you how to do that on your graphing calculator. So let me just go to calculator real quick. So if I were to take 500 divided by 360, just leave the pi out of it, you always get this decimal. Well, if you go to math and then number 1 is to fraction, you hit enter, you'll get the reduced fraction version of it, which is 25/18. Okay? So that's just something quick you can do to get a nicer answer. And then that, of course, is in meters. Okay? So a couple ways to write your answer. The fraction is best. It's more exact because you didn't reduce or you didn't simplify anything. All right, here's one you can try on your own. Please find the arc length of CD. So you can pause the video and work on that. So I want to find the length of that arc. So I know the measure of it is 100, but I don't know the length. So x out of, and then I need to do 2 pi r. Well, 2 times 7 is 14, so 14 pi equals 100-degree arc out of 360. So 360 times x equals 100 times 14, or 1400 pi. And then go ahead and let's practice the dividing out 360. I don't think this one divides evenly. So again, try to get that very nice reduced fraction by using math fraction. So 1400 divided by 360 is like 3.8 repeating. But then if I do math fraction, I get 35/9. So 35 pi over 9, and that is centimeters. And that's how long the arc is. All right, the last part of our lesson, we're going to actually work on sector area. Okay, so now we're looking for the area of just like a portion of the circle. So a sector is basically, it's a region of the circle, okay, that's enclosed by 2 radii and an arc of the circle. So that's basically what we see here. Like this is like sector area. So we're wanting to know how many square units that is contained in that little area. So sector area is a fractional part of the area of a circle. So this proportion we're going to use is very similar to the one we did for arc length, but for sector area, we're instead of using circumference, we're actually going to be using the area formula down here. So sector area over the area of a circle equals arc measure out of 360. So we're just using a fraction of the area. So we're just, instead of 2 pi r or pi d, we're going to use pi r squared this time. So let's try one. It says find the area of the shaded sector. Leave your answers in terms of pi. All right, so sector area we don't know, so that's x. And then the area of this circle, pi r squared. So we have to do pi r squared. Well, the radius would be 4. So 4 squared is 16. So 16 pi equals the arc measure, 80 out of 360. Oops, I'm sorry. The arc measure is not 80. 80 is this arc. So what would the other arc be? Glad I caught that. What would the other arc be then? So I see a semicircle. It's actually 100 degrees. Okay, to make a semicircle. So we'll have to use 100 degrees out of 360. All right. So now we do our cross products again. So we'll get 360x equals 1600 pi. Divide by 360, and again use a nice fraction reduced. So 1600 divided by 360 is not a nice number. It's 4.4 repeating, but since they want terms of pi, we're going to go ahead and use a really nice fraction. So let's do math fraction, and you actually get 40 over 9. So 40 pi over 9, and this would be feet squared because we're talking about area now. That will be feet squared. All right, we can't do any circle problems without talking about pizza at some point. So we finally get a pizza problem. Although this one has pepperoni on it, which I do not like. It says, suppose a pizza is divided into 8 equal pieces. Okay, the diameter of the pizza is 16 inches. We want to answer 2 questions. So first, what is the area of one piece of pizza? So to me, that feels like sector area. Okay. Then it says how much crust will be on one piece of pizza. So crust, that's really just kind of like your arc length now. So we have, a couple things to do. So let's start with the how much area. If we divide this pizza into 8 equal slices, how much area is it? All right, so now first this we'll have to start with sector area formula. So we're going to use the sector area x out of the area of the pizza. So pi times radius squared. It says the diameter is 16. That means radius is 8. So we've got like an 8 right here. So that means 8 squared is 64. So 64 pi is the area of the pizza. And then the arc measure, what's the measure of one piece of the arc of one piece of pizza? Since we divided this whole circle 360 by 8 slices, say 8 equal pieces, although we know they're never really equal, someone always gets bigger. 360 divided by 8 is actually 45 degrees. So each slice, we know the measure is 45 degrees out of 360, approximately. All right, let's go ahead and solve for the area of the pizza, of the one piece of pizza. So we're going to do 360x, like we always do, and then 45 times 64, which is 2,880 pi. Divide by 360, and I think this one comes out nice. Divide by 8. And so divide by 360, we get 8. So 8 pi. So x is equal to 8 pi inches squared. So you're going to have 8 pi square inches of pizza. Well, most people don't really know what that is. So if you wanted to, you could actually tell them how many square inches that they're going to get. So 8 times pi And you would get about 25 square inches of pizza. So everybody gets 25 square inches of pizza if we cut it into 8 equal slices. Okay, now some people throw away the crust, which I think is terrible. I love the crust. So let's see how much crust will be on one piece of pizza. So now we're talking arc length. Okay, so now we're going to do x out of, now we need the circumference. So if the diameter is 16, circumference is going to be 16 pi. And then, of course, we know the piece of pizza is a 45-degree arc out of 360. So we'll solve 360x equals 45 times 16 this time, which is 720 pi. Divide by 360, divide by 360, and 720 divided by 360 is actually 2. So you get 2 pi inches of crust on each piece, which again, if someone doesn't really know what that is, it's approximately 6.3 inches if you multiply 2 times 3.14 of crust. And again, that's just inches, not inches squared, because that's a linear measurement. All right, I think we have one problem left. I think this is it. We just want you to go ahead and try a sector area problem on your own. So if you would pause the video and find the area of that sector of the circle. Okay, so hopefully you are able to set up the proportion. So the area of the sector out of the area of the circle, which is pi r squared, r is 9, so 81 pi, equals the arc measure 20 out of 360. So we'll get 360x equals, now 20 times 81 I think is also, we end up with 1620 pi. And now if I divide by 360, I think it divides out nicely. We get pretty nice. It's 4.5 pi, or you could write it as 9 over 2. And then that's going to be inches squared. X equals 9 over 2, or 9 pi over 2 inches squared. And those will be a couple different good ways to write your answer. 4.5 is not really approximated, so that would be okay. All right, so that is it for Unit 6A videos. If you have any questions about any of these lessons, please ask.